Hello, everyone. So today we're going to look at some applications of trigonometry, specifically with Ferris wheels. So let me go ahead and present this. I don't want to present a window. I want to present the whole screen. Okay. All right. So looking at this right now, one of the most common application questions for graphing trig functions involves Ferris wheels, since the up and down motion of a rider follows the shape of the sine or cosine graph. Before we get into the example, we're going to draw this out so we have it as well. So let's look at this. We have a circle. That's my little Ferris wheel. This is where it connects, and this is the ground. So the ground is going to be the x-axis, whatever that happens to be. Now, my minimum is right here. And so I'll put a dot there. And this is my maximum right here, but it is off the ground. So this isn't usually going to go through the x-axis. And then we have a midline right here. That's your midline. If you need to find your midline, max minus your amplitude will give you your midline, or your minimum plus your amplitude will give you your midline. And then a good thing to know is that your radius, not your diameter, but your radius is going to be your amplitude. And that's going to be a really easy way to figure this out. Also on here, just so that we remember, I'm going to put that amplitude is equal to max minus min divided by 2. And your midline is equal to max plus min divided by 2. And hopefully that'll help us out a little bit as well. Okay, so I'm going to try and keep this in our field of vision as much as possible as we go through this question. A Ferris wheel has a diameter of 30 meters with the center 18 meters above the ground. It makes one complete rotation every 60 seconds. So this right here, I can tell you, is the period, because that's how long it takes to go around. Since the center is 18 meters, that is the midline. Now we're going to draw a graph of one complete cycle, assuming the rider starts at the lowest point, so the minimum. Find the cosine equation of the graph. What is the height of the rider at 52 seconds, and at what times is the rider at 20 meters? So when you look at a Ferris wheel, it makes a circular motion. We're not going to draw a circle on our graph. The graph represents the up and down motion over time. In the first half of the graph, we can see that the person will go from 3 meters to 33 meters in 18 seconds. In the second half, the person will go back to 3 meters. We'll talk about how I got those numbers in just a second. So let's first start with graphing this. So it says that the midline is at 18. So I'm going to go to 18, and I'm going to sketch in a midline. It's not going to be perfect, but I'm going to do the best that I can. So this is my midline, which means that half of this is above it, half is below. Now I said the radius is your amplitude. So if 18 is my midline and the radius is my amplitude, the diameter is 30, so my radius is 15. Now 18 plus 15 will give me my maximum. 18 minus 15 will give me my minimum. So 18 plus 15 is 33. So my max is 33. My minimum, 18 minus, and I got this from 18 minus 15, or 18, sorry, plus 15. 18 minus 15 gives me my minimum, which is 3. So I'm going to start down here at 3. Now, I'm going to hit my maximum halfway through this ride, and then I'll hit my minimum again at the end of this ride, which is 60 seconds. Now, halfway through 60 seconds is at 30 seconds. I will be at 33, which is right here. So if we draw this, it'll look something like this. Again, I'm not perfect at drawing these functions. I apologize. All right, let's try and go through some of this wonderful question. So the A value, remember, the A value is your max plus your min divided by 2. So 33. Sorry, max minus min divided by 2. 33 minus 3 divided by 2, which is 30 divided by 2, or 15. It's also your radius. Radius. Now, the big thing here, though, is it starts at the minimum. Remember, we always said cosine starts at a maximum. And if it starts at a minimum, that means it's been rotated. So one thing we have to be clear about here is negative 15 is your actual A, and that's because it starts at minimum. So that is your actual A. Now the B value. So the period is 60 seconds. So to find B, we do 60 divided by 2 pi. Remember, that is our equation to find B. Never. I apologize, guys. I am having a brain fart. Sorry. Our equation is 2 pi divided by 60. It's always 2 pi on top. So 2 pi divided by 60, which reduces to pi over 30. Again, it's always 2 pi either divided by the period or divided by b to find the other one. Now the c value. The c value is also known as the h value. And there is none because we haven't had a translation left or right. And the h value is also known as the k value. And here, the k value is your midline. How much did I move up? It's your midline. So k equals 18 because my midline equals 18. So that means the equation of the Ferris wheel is going to be y equals a, negative 15. And we said this is a cosine function. It's a cosine function because we're starting at a min or a max. That means it's a cosine function. So cosine, my b, which is pi, divided by 30. Ooh, Bug wanted to come say hi and just sit on our work. Sorry, Bug. And then you do theta or x, either one is fine, plus our k, which is 18. So that is our function right there. And we can put that into Desmos. And I'm going to do that now to make sure that this looks like that, what we're supposed to have. So y equals negative 15 cosine parentheses pi divided by 30 x and parentheses plus 18. And here we get our cosine function. We have a y-intercept at a minimum at 0,3, a maximum at 30, 33, and it ends at 63. One full period ends there. All right. Now let's look at questions C and D, and we'll be able to use our graph for this. So plug 52. So for C, it asks, what is the height of the rider at 52 seconds? And remember, time is your x-axis. So you could plug 52 in for x and then simplify. I suggest just plugging 52 in for x right here. So we plug 52 in. And what we can do is we can come right here and see that 52 is equal to 7.963. 50. So is 52, 7.963, which means my height is equal to 7.963 meters because we're working in meters. So if I go back, that was my point, and that's what I can do here. Now you can also do this in your graphing calculator. This is the method for it, but we use Desmos. It's okay if you don't. Now the same thing can happen. You can use your graphing calculator or Desmos to find the height at 20. But height is your y, so it would be y equals 20. If I can type today. And at y equals 20, remember, we're only doing this first period. So I have 16.27720 and 43.72320. Now it asks for find the times that the rider is there. So the rider is there at 16.277 seconds and 43.723 seconds. And that's when you're at 20 meters of height. Okay. Let's keep on trucking. Now, in some Ferris wheel questions, You'll be given the rotational speed in units of revolutions per second or revolutions per minute. And then we can calculate, or we can find these values to find the period as follows. So a Ferris wheel rotates at 4 revolutions per minute. And we need to know how many seconds it takes. What is the period in minutes and seconds? So think of it this way. There are 60 seconds in a minute. If it completes 4 revolutions, each one must take only 15 seconds. Thus, the period is 15 seconds. Or we can take 60, divide by 4, and we get it takes 15 seconds. And that's what you're going to do. Okay, so a Ferris wheel has a radius of 35 meters. So already I know that's my A. And starts 2 meters above the ground. So that's my minimum. It rotates once every 53 seconds. That's my period. Determine the cosine equation of the graph if the rider gets on at the lowest point. So the lowest point is 2 seconds, right? Or 2 meters right here. And the radius is 35. So that's my A. So let's start talking about this. I know my A is 35. Now, this is 2 is the minimum. 35 will get me halfway. So the midline is 35 plus 2, which is 37. So my midline is at 37. Which is about here. There's not a great place for it. So that's my midline. I have my period, so I need my B, which is 2 pi over 53. There's no way to reduce that. So I have that. And since we start at the lowest period, my A is going to actually be a negative 35. Okay, so now that we have that, we write our equation. Y equals negative 35 cosine 2 pi over 53 theta plus 37. So there you go. Now this one says sketch 2 complete cycles of a graph representing the height of a rider above the ground, assuming the rider gets on the Ferris wheel at the lowest point. So at 53 seconds, which would be about here, we're going to hit the lowest point again because I've made 1 full revolution. And then at 106 seconds, 53 plus 53, 106 seconds, I'm going to hit the lowest point again because that's 2 full revolutions. Now I need to find the maximum. So 53 divided by 2 will be my halfway point and where I get to the maximum, which is at 26.5 seconds. So at 26.5, and it doesn't have to be perfect, I'm going to get to my maximum. Now my maximum is going to be like the midline, so 37 plus another radius of 35. So 37 plus 35 is 72. So at 26.5 seconds, I get to 72 meters, and I do it again. 53 plus 26.5 is 79.5. So at almost 80, I get there again. And this is a sketch. It doesn't have to be perfect because as you can see, I'm not the best at drawing these. And there you go. So what is the height of the rider at 81 seconds? So the height at 81 seconds, remember seconds is your x. Let's put this new equation in. So I have y equals negative 35 cosine parentheses pi, and it's actually 2 pi divided by 53 x parentheses plus 37. So here's this one, and I need to know when x is 81. So x equals 81. And that's going to be at 70, the height's going to be 71.448. So it's right after the second, making it to the top the second time. So that's your height. At what time does the rider first? So just the first time it reaches a height of 51 meters. So we're going to put y equals, because height is y, 51, and the first time it hits there is right here at 16.721 seconds. That is the first time it hits there. And sometimes you're going to have to see these abbreviated in different ways, but that's going to be it. Okay. Sorry about that. So going back. Now for this last one, I highly recommend trying it yourself before I do it, but you are welcome to do it with me as well. A Ferris wheel makes 4 revolutions in 1 minute. So the period, 4 revolutions in 1 minute, 60 divided by 4 equals 15 seconds. The diameter of the Ferris wheel is 28. So if the diameter is 28, that means the radius is 14. And that also means A is 14. And a rider boards a platform at a height of 30 meters above the ground. So we're getting it at the top. The ride lasts 30 seconds. So if each revolution is 15 seconds, there's 2 revolutions in 30 seconds. And we're starting, the maximum is 30. All right, so it says determine the cosine equation. After we determine the cosine equation, we're going to sketch the graph, and then what height does it make it to here. So we know that A equals 14, and we know it starts at 30. So let's put a dot at 30. Now, 14 is my A. My radius is 14 for my diameter. Hello, Doe. My diameter is 28. So I'm hitting the end of this 28 meters below this, which is at 2. So my minimum is 2. I'm going to put that up here. That's going to help. My midline is going to be my maximum minus my amplitude. So 30 minus 14 is 16. Or remember, you can add these two and divide by 2. 30 plus 2 is 32. Divided by 2 is 16. So my midline is 16. So at 15 seconds, I'm going to hit my maximum again. And at 30 seconds, I'm going to hit it again. Halfway between, so 15 divided by 2 is 7.5. Halfway in between, or at 7.5, I'm going to hit my minimum of 2. And 15 plus 7.5 is 22.5. I'll also hit my minimum. So we can sketch this. I'll sketch in my midline real quick. It's kind of a crappy dotted line. I apologize. And we sketch this. Now to write this equation, we're starting at the top. So this is a normal cosine function. So it's not reflected. We can start with 14 cosine. Oh, I need to find my b really quickly. B is equal to 2 pi over the period, which is 15. So it's 2 pi over 15. So I get y equals 14 cosine 2 pi over 15 theta plus 16, my midline. Okay. And now I need to know at what times, so this is all the times, the rider is at 20 meters. So let's put this into Desmos. We have 14, 2 pi over 15, and then this is 16. And I need to know when y equals 20, because it's meters, and meters is height. So we're right here. The first one is 3.058. So 3.058 seconds. The next one is at 11.942. The next one is at 18.058. And the last one is at 26.942. And all of these are seconds. So I should write seconds under all of them. And we did that because it was 2 full revolutions. So we had to know at 20, it's hitting here, 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 here. There's 4 of them. 1, 2, 3, 4. All right. You guys are going to be doing a task like this today. Again, I apologize for the mistakes today. Really trying my best to stay on this. It is a lot of math, and I really do have to check myself as I go through, so I recommend you guys do the same. I hope you have a wonderful day. We'll have one more day of applications, and then you'll have your study review guide, and then you have your assessment on this. I believe in you guys. Have a wonderful day.